Hi, welcome to Algebra 2 Common Core. Today we're going to revisit the quadratic formula. You were first introduced to this back in Algebra 1, so today's lesson should be a review of what you saw back in Algebra 1. We're going to start with exercise number 1, where we're going to solve the quadratic equation that we're given by using the method of completing the square. So the quadratic equation that we have is x squared minus 6x plus 1 equals 0. So let's remember how to do the method of completing the square. First of all, we're going to start by moving the constant over to the right side of the equation. So that's going to leave me with x squared minus 6x. Now remember that I want to get a trinomial that's a perfect square trinomial, so I'm going to leave a spot for a constant that will be added in, and we'll talk in a minute about how to get that constant. Let's subtract 1 from both sides of the equation, so now that 1 is a negative 1 over on the right side. Now remember what we do to complete the square. We're always going to take the coefficient of the x term. In this case, it's negative 6. We're going to take half of it. That gives me negative 3. And then I'm going to take that number and I'm going to square it, and I'm going to put it in that spot where I'm adding it to the left side of the equation. Now negative 3 squared, of course, is positive 9, so I'm going to add 9 to the left side of the equation. We should recognize that left side as being a perfect square trinomial because we'll be able to factor it by multiplying two of the same binomials together. Now, given the fact that we have just added 9 to the left side of the equation, we want to again go ahead and add 9 to the right side of the equation. So there's the 9 that we added on the left. Let's add it to the right side as well. So now we have on the left side x squared minus 6x plus 9. We should recognize that as x minus 3 quantity squared. Remember, when we do our factoring, we're always going to use that half number that we had in the step before, and that becomes one of the terms in my binomial. On the right side, let's go ahead and add negative 1 plus 9, and that gives me 8. Now our goal is to solve for x, so we're going to take the square root on the left side, and when we take the square root on the left, we also have to take the square root on the right. But remember, on the number side, we're going to take the positive and negative square root of 8. So on the left side, the square root of x minus 3 squared is just x minus 3. On the right side, let's use some of those simplifying radical techniques that we've been using in this chapter. So we see that 8 is really 4 times 2. The square root of 4 is 2. But then that leaves a 2 still underneath the radical sign. If you need to review that, go back to your notes on lesson number 1. Now what we'd like to do, actually it might be also lesson number 2. What we want to do is solve for x. So we are going to take our answer and we're going to add 3 to both sides of the equation. So we now have the solution. X is equal to 3 plus or minus 2 radical 2. Now we did this by the method of completing the square. This is an exact solution. Notice that we really have two answers here. We have the solution 3 plus 2 radical 2, and we also have the solution 3 minus 2 radical 2. These two numbers are both irrational. They have a radical part that cannot be simplified, so I have two irrational answers. You'll notice that they're actually related to each other. One is 3 plus 2 radical 2, the other is 3 minus 2 radical 2. Those two answers are called conjugates because they're the same exact numbers, one with a plus in between and the other with a minus in between. That should become familiar to us as we progress through the rest of this unit. Now, quadratic equations can be solved by the method of completing the square. If we start with a standard quadratic equation, y equals a times x squared plus b times x plus c. We can actually go through the method of completing the square with that trinomial to see our solution in a general form. What happens when we do that by completing the square is we get a formula for solving for x. We're going to go over that step of getting this formula tomorrow in class. But for now, I'm going to tell you that the quadratic formula says if I want to solve for the roots of a quadratic equation, I'm going to take the coefficients a, b, and c. And with those coefficients, I'm going to plug them into what we know as the quadratic formula. X is equal to the negative of b plus or minus the square root of b squared minus 4 times a times c all over the denominator 2a. Now for a challenge, you could try taking that equation ax squared plus bx plus c equals 0 and see if you can go through the steps of completing the square to see this quadratic formula. If you don't get it, we're going to be looking at it tomorrow in class so that I can show you where this formula actually comes from. In our notes today, in the video today, I really want you to get very familiar once again, like you were in Algebra 1, with solving quadratic equations using this quadratic formula. So let's all take a look at exercise number 1. Solve using the quadratic formula, x squared minus 8x plus 14 equals 0. My first step is to identify the coefficients a, b, and c. Now a is always going to be the coefficient of the x squared term. So in this case I see that a is just equal to 1 because there's no other coefficient written down there. My b is always going to be the coefficient of the x term, and in this example I see that b is equal to negative 8. And for my last constant, c, that is always going to be the constant in my quadratic equation. So in this case, c is equal to 14. So it's important to identify the a, the b, and the c for each quadratic equation. You'll notice that that quadratic equation had to be written in standard form first. If it wasn't already in standard form where the x squared term came first, then the x term, and then the constant, then you need to first of all put it in standard form. Now we're ready to apply the quadratic formula. So I'm going to say x is equal to the negative of the b term, so negative of negative 8, plus or minus the square root of the b term squared. Now it's really important because this b is a negative number, I'm going to put that in parentheses and square the whole thing. And then I'm going to subtract 4 times the a term times the c term. And then I'm going to divide by 2 times the a term. Now, yes, you want to get out your graphing calculator so that you can do these calculations. Obviously, it's also possible to do it in your head, but sometimes we end up with some very large numbers. So pause the video for a minute if you don't have your calculator and go get it. So for this one, I'm going to say x is equal to the negative of negative 8, which is positive 8, plus or minus, and then I'm actually going to go straight to my graphing calculator, and I am going to type everything underneath the radical, parentheses negative 8 squared, minus 4 times 1 times 14 into my calculator. I'm not going to use the square root sign yet. I'm just going to do the number part. When I do that, I ended up with 64 minus 56, which actually just gives me the number of 8. But again, you can just do the whole thing by typing it into your calculator and see that that simplifies to 8. All over 2 times 1, which is 2. Now, we first of all have to simplify our radical, and then we'll go ahead and divide by 2. So I'm going to say 8 plus or minus. Now, like in the example above, the square root of 8 can be broken down into the square root of 4 times the square root of 2. The square root of 4 is 2 times the 2 that's still underneath the radical sign, all divided by 2. Now, it's really important when I'm simplifying in this last step to make sure that we're dividing both this number here and the coefficient of the square root, both by this denominator. So when I do that, 8 divided by 2 gives me 4, plus or minus 2 divided by 2 is 1. 1 times radical 2 is just radical 2. So you'll notice that this really is two answers, 4 plus radical 2 and 4 minus radical 2. Again, these two answers, both answers, are irrational because they both have a radical part still in them. If I were to plug them into my calculator, I would see that I would get a decimal that does not end and doesn't repeat. So it's a non-terminating, non-repeating decimal. The other thing you'll notice is that they are the same two numbers, one with a plus between, the other with a minus. So these two solutions are also called conjugates. Let's move ahead to example number 2. We want to solve for the solution of the quadratic equation x squared minus 10x plus 20 equals 0. Now, if I don't see an easy factoring to do, then the quadratic formula is a great alternative. You'll notice that this is a multiple choice answer, so I'm going to be eventually picking one of these multiple choice answers. Back to my original quadratic equation, I'm going to identify the a. So a is equal to 1 because that's the coefficient of x squared. B is equal to negative 10 because that's the coefficient of x. And c is equal to 20 because that's the constant. Again, you'll notice that when I looked at my quadratic to begin with, it was in standard form. So now go ahead and substitute into your quadratic formula. X is equal to the negative of negative 10, so that's positive 10. Plus or minus the square root of b, which is negative 10 squared, minus 4 times a, which is 1, times c, which is 20, all over 2 times 1. Now go ahead and use your calculator to simplify the number underneath the radical. That's called the radicand. So I have 10 plus or minus. In this case, I get the square root of 20 over 2. Now, whenever possible, I want to simplify that square root. So see how 20 has a perfect square factor? So I'm going to say x is equal to 10 plus or minus. 20 is really 4 times 5. So the square root of 4 is 2. 5 is not a perfect square, so I'm going to leave that part underneath the radical. All over 2. If you have to, you can go off to the side and say, okay, for the square root of 20, 20 is really 4 times 5. 4 is really 2 times 2. Anytime I have a pair of factors, that comes out, and that becomes the coefficient of the radical. In this case, the 5 stayed underneath the radical sign because it didn't have a partner. So, going ahead and dividing both the numerator and denominator by 2, I'm going to get for my solutions for x, 5 plus or minus 1 radical 5. So again, that represents two solutions, 5 plus radical 5, 5 minus radical 5. I look back to my solutions here, my multiple choice, and I see that this looks like choice number 4. These are two irrational solutions, and again, they are conjugates of each other. Now in exercise number 3, we're going to solve the same quadratic equation in two different ways. Let's go back to our factoring technique. For part A, 2x squared plus 11x minus 6 equals 0. We want to factor this. So given the fact that I've got a coefficient in front of the x squared, that tells me that I have to multiply. Remember, I'm going to multiply 2 times negative 6. I need to multiply to get negative 12, but I need to add to get 11. So thinking about this, I think I'm going to use positive 12 and negative 1. I'm going to put an x with each of them. I like the box method. If you prefer grouping, you can go ahead and do that. So let's just review our box. I'm going to put a 2x squared right here. These two go in either of my diagonal spots. So I can say 12x and negative 1x here, and then negative 6 at the end. In the first row, I've got a 2x common to both. In the second row, negative 1. In the first column, x. In the second column, 6. So my factors are 2x minus 1 times x plus 6. Now we are solving because we have an equation set equal to 0. So let's make our t-bar. For the easy one, I see that x is equal to negative 6. For the other one, let's add 1 to both sides of the equation. So 2x is equal to 1. So therefore, x is equal to 1/2. Now this time I got two solutions. They're not irrational. They are rational. They can both be written as a fraction. In the case of negative 6, that would be negative 6 over 1. Now I'd like you to take a minute and try to solve part B using the quadratic formula. Come back when you've completed that and check your work with mine. Let's take a look at my partial solution. Notice I haven't simplified my radical yet. I identified A as 2, B as 11, and C as negative 6. So substitute those values into our quadratic formula and see that we get a square root of 169. Well, 169 happens to be a perfect square, so I'm not going to have a radical left in my answer. So right now I've got negative 11 plus or minus the square root of 69, which is 13, all over the number 4. So let's look at those two possible answers, because I think I can go one step further. In the left side, I'm going to say negative 11 plus 13 divided by 4. And then my other solution will be negative 11 minus 13 divided by 4. Negative 11 plus 13 is 2, so 2/4 gives me the solution 1/2. In the second case, I'm getting negative 24 over 4, so I'm getting a solution of negative 6. Do you recognize that those are the same exact solutions that I got when I solved this equation by completing the square? By factoring in part A. So now we see that we actually have 3 ways to solve quadratic equations: by completing the square, by factoring, but also by the quadratic formula. Completing the square always works. The quadratic formula always works. But not all quadratics are factorable. So if something looks like it's going to be easy to factor, I would use factoring. If it's not easy to factor, then I would use either the quadratic formula or completing the square. Let's go ahead to the last 4 examples here. I'm going to start with A, and the instructions say to please use the quadratic formula. So for A, I'm going to identify that A is equal to 3 because that's the coefficient of x squared. B is equal to 5, and C is equal to 2. So for our purposes, it is really important that with practice you learn the quadratic formula. In the end, it is going to be on our Algebra 2 formula sheet, but I think it's something that's going to be much easier for you if you do know the formula. So I'm going to say x is equal to the negative of b, so negative 5, plus or minus the square root of b squared minus 4 times 3 times 2, all over 2 times a, 2 times 3 is 6. I'm going to go ahead and simplify that, so I get x is equal to negative 5, plus or minus, and this is the part where I literally just go to my graphing calculator. I get the square root of 1, but the square root of 1 is just 1. So negative 5 plus or minus 1 divided by 6. Here's another one of those examples where the roots are rational. There's no radical left in our answer. So I'm going to simplify my two rational answers. Negative 5 plus 1 over 6. That's giving me negative 4/6, but negative 4/6 reduces to negative 2/3. The second answer would be negative 5 minus 1 divided by 6. Negative 5 minus 1 is negative 6. Negative 6 divided by 6 is negative 1. So I have two solutions for this quadratic equation. Now remember again what would happen if I were to look at the graph of this quadratic. These two answers, these two solutions that I just found, are also called the roots of the quadratic. The roots are the same thing as the x-intercepts. So I could say that my x-intercepts for this graph are going to be negative 2/3 and negative 1. I'm going to skip over B and I'm going to go to C to work on together. So for example, C, I've got that A is equal to 2, B is equal to negative 2, and C is equal to negative 5. Whenever you're working with the quadratic formula, I want to see you write down the values for A, B, and C. So the quadratic formula says x is equal to the negative of b, so negative of negative 2 is positive 2, plus or minus the square root of negative 2 squared minus 4 times 2 times negative 5 all over 2 times a, which is 4. So calculating the radicand once again, I'm getting the square root of 44 divided by 4. Now, 44 does have a perfect square factor. If we think about this, 44 is really 4 times 11. 4 is a perfect square, so I can take the square root of 4, so that's going to be 2 plus or minus 2 radical 11 all over 4. Now, whenever I'm looking to simplify, I'm going to look for this number, and this number to all be divisible by the same thing. In this case, they're all divisible by 2, so I'm getting x is equal to 1 plus or minus 1 radical 11 all over 2. So this simplification was a little bit different when you took a look at it. Again, these are two irrational roots because they still have a radical in them. What would this mean on my graph? If I were to graph this quadratic, 2x squared minus 2x minus 5 equals y, I could use my calculator to find the decimal equivalents or the decimal approximations to these answers. And that would be the two places where my graph crosses the x-axis. Now, please pause the video and do part B and part D on your own. I want you to show all of your work and then come back and check your answers with my answers and see if they match up. When I'm checking your notes tomorrow, I want to see all of your work. I'm only going to be giving you the answers, but I want to see that you've completed all the work. For example B, your solutions are two irrational answers, x equals 4 plus or minus radical 3. And again, that means two solutions, 4 plus radical 3 and 4 minus radical 3. Those are conjugates of each other. For D, my two solutions are rational answers, x equals negative 2 and x equals 2/5. Whenever I end up with two rational answers for a quadratic equation, that means that that quadratic could have been factored. So that would have been an alternative way to solve this quadratic for the roots. If you have any questions, please come and see me during activity period. Otherwise, we'll be practicing quite a bit with the quadratic formula tomorrow in class. Please make sure you're starting to get used to what that quadratic formula is, because I think it's important for you to know the quadratic formula. Have a great night, and we'll see you next time.